Okay. Mm. Hello, good afternoon, everyone. So it's another insightful edition of the Precision Agriculture Incubation Program, and this is another week. So we are starting a new series this week, and we are going to be talking on the topic geospatial technology and driverless farm machineries. So our speaker is going to be joining us soon. So I'm trying to get in touch with him now to come on board so that we can kickstart. Okay, so all right. So before we go into our speaker introduction, okay, so let me quickly talk about the organizer of the program, Precision Field Academy. So we are Precision Field Academy, and the Precision Field Academy, we have the vision to create a world where every young person, regardless of their background, has the opportunity to become a digitally savvy farmer or agricultural professional, driving sustainable and equitable growth in their communities through the transformative power of technology. And our mission is to raise the next gen farmers that are tech inclined and digitally savvy. So at World Christian Field Academy, we are a social enterprise. We train and build the capacity of young professionals in modern and emerging technologies for the future of work and to lead with precision agriculture. So what's a methodology? We have three core methodologies. Number one is education and knowledge sharing. Number two is training and skill development. Number three is coaching and mentorship. And we also have certain tech skills in focus. So our tech skill acquisitions are in the area of drone technology, uh, geographical information technology and remote sensing, data science in agriculture, robotics and internet of things in agriculture, artificial intelligence and machine learning, lastly enterprise development. So why do we do what we do? What's our motivation for starting Precision Field Academy, and what's our motivation for doing what we are doing at Precision Field Academy? So we discovered there is a skill gap that really needs to be closed, and young professionals need to build the skill set on both technical and enterprise skill set for the future of work in agriculture, because we are in evolving world and the reality of every day is different. So the solution of yesterday is not sustainable to solve the problem of today, and youth need to get informed. They need to get engaged with this evolving technology to be able to navigate their ways around problems coming forward. Number two, we discovered that observing the trend is not enough. Being awed or being amazed at new technology that has been released in different parts of the world is not enough. So, youth, I mean, African youths generally need to become an enabler and a player in the fourth agricultural revolution, and not just mere observer. They need to look into how they can start designing solutions that can help us solve our problems sustainably. And number three, technology is the key to unlock African agricultural potential. So, leveraging on technology, we can transform the agricultural landscape in Africa. So, why should you join us? The reason why you should join us at Precision Field Academy is that we are creating the future we want in agriculture. We emphasize this future, and we are building momentum, raising the capacity of youth to create a future we want in agriculture. Also, we connect you to the world of information and opportunities in terms of scholarship programs, internship, volunteership, opportunities on both local and international scale for your career growth. Also, we have skill development, and this is done through project collaboration, community interactions, and workshops. And lastly, you have access to coaching and mentorship from industry leaders and professionals around the world. And that's where we have programs like this giving you access to seasoned professionals and experts in their field, sharing their knowledge uh, and exposures. So at Precision Field Academy, we are building a community of young, inclined, and digital savvy professionals. Thank you. So let me quickly give a quick introduction about our speaker for today, Mr. Noah Obafemi. Okay. So, like I said earlier, today's topic is geospatial technology and driverless farm machineries. So, Mr. Noah Obafemi is our guest speaker. He is a regional sales manager for a company called CHC NAV. So let me quickly read through his profile before we bring him on board. Mr. Noah Bafemi is a regional sales manager for CHC NAB. His mission is to drive growth and innovate geospatial solutions in Nigeria and Africa. With expertise in land surveying and strategic business consultation, it focuses on expanding market presence and nurturing customer relationships to meet the diverse needs of the regions. His proficiency in geographic GIS technology and advanced surveying equipment ensures delivery of tailored and reliable solutions. His role as a principal surveyor at Acleon Nexus Limited has earned his ability to offer strategic guidance alongside with technical surveying services excelling in land title documentation, cadastral and topographic mapping, which are crucial for client success. By aligning technical precision with business strategy, it empowers clients to optimize operations and achieve sustainable growth, reflecting on its commitment to excellence and innovation in the geospatial domain. Okay. Hello, Mr. Noah, are you there, sir? Hello, please if you are there, let me.
Uh, Hello, can you hear me?
Hello, sir.
Can you hear me?
Hello, Mr. Noah, I don't know if you can hear me, sir.
I can hear you. Can you hear me?
So sorry, everyone. We're actually waiting for him to come on board
Hello,
to
can you hear me?
come together. Hello, Mr. Noah. Can you hear me, sir? Hello.
I'm available online. Can you hear me?
Yes, 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 yes. I can hear you very well, sir. I can hear you.
Okay. Thank you so much. But I'm actually currently having issue being able to upload my presentation. I don't know because it's my presentation is quite a large file. So and it's
Okay. I
giving
don't
me
know if you
limited.
can send it to the mail so I can get it from there to upload here.
I can send it to where?
The mail, the email I sent to you earlier. Precision Field Academy.
Can I share my screen instead? Is it possible?
Okay, okay. Yes, yes, yes. I believe you should be able to share your screen
So
from
where
your
do I need
end.
to go? Where do I need to go to share my screen?
Okay. Wait, I don't know. Can you see present from your hand? Present.
Yes, I can see
So
present, but it's
yeah.
asking me to. Oh, okay. Share screen. Oh, okay. Great,
Okay.
great, great,
All right.
great. Just a minute.
Okay, sir.
Can you see my screen?
Mm, yes, yes. Okay. Let me bring it to the stage. Okay.
Okay.
All right. Okay, sir. Building a smart world with precise geospatial information. Okay. So I think we are good to go, sir.
So
Okay, you can
you
go
can
ahead,
see my
sir.
screen now, right?
Yes, sir. Yes, I can see it. You can. Yes, yes.
Can you help me confirm? Can you see my screen?
Yes, sir. Yes, sir. Yes, sir. I can see your screen. I can
Okay.
see your screen. You have the floor, so you can
Thank
go
you.
ahead, sir. All right, sir.
Good afternoon, everyone. It's afternoon here in Nigeria. Good afternoon, everyone watching. My name is Noah Bafemi, as earlier introduced. and it is a great privilege to be here to be able to share knowledge with now in the global world. And by privilege being a surveyor in practice, now in the era whereby so much of technology has been applied to equipment, even go to sites without really going
Hello, everyone. So we are sorry, we are having network issues here. So, and I think it's raining in my environment, and I don't know what's happening from his end too. So that's the reason why he's not here now. So we're trying to solve it to bring him back to the States. Just give us some few minutes to fix that. Thank you. Okay, thank you very much, everyone. Yeah, sorry for the network glitches. So our speaker is back now. So let's keep moving. So you can try to upload your slides or share your screen again. So we can. Hello, sir. Can you hear me now, Mr. Noah? Can you hear me, sir? Uh, Hello, sir. Hello, can you hear me, sir? Are you still there? The network is very poor. Hello, sir.
Hello, can you hear me now?
Yes, 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 I can.
Okay.
You
Yeah.
can share your screen
So
now. Or
because I just noticed I've been talking and I didn't know that it has gone off.
oh, sorry.
Okay. I'll share the screen again now.
Okay, no problem, sir.
So I'll just go back a bit because I'm not sure where
Okay,
I
okay,
stopped.
okay. I can see your screen now. I can see your screen, but you can
Yeah, so I'll
try
just go
to
back
give
a
a
bit.
recap.
Let's go back a bit because I know I've I've been speaking. So maybe I'll just start from here. So, like I said before, so that when we are talking about geospatial, now all we are talking about is location. Now, being able to determine the spatial data of a particular location. And when we mean spatial data, we are talking about the coordinate system or the coordinates itself of that particular place. So anything related to location, then we are talking about geospatial data. And the reason why this is very, very important is the fact that it gives us the ability to be able to differentiate a particular object at a particular point from another object, either closer to it or far away from it. So you don't mix them together because their coordinates cannot be the same. Their coordinate cannot be whatever makes their coordinate to be the same means that they are both exactly on the same point.
Okay,
So even when you have that data on the same point, there are still some things that can make you to know maybe the data is underneath, the object is underneath the other object, or the object is above the other object. And that's the essence of the XYZ. So even if the XY is exact, now when you look at the Y, you can be able to determine that, oh, I think this data is underneath this particular object, and or this data is depicting that this particular object is above that object. So when we say geospatial data, all we are looking at is various geospatial technology which are able to achieve data collection in the aspect of being able to determine the geographic components of a particular thing. So the only thing that we are interested in is the geographic component of a particular thing in geospatial data. The moment we are able to deduce the geographic component, then we can be able to implement or enhance some other technologies to be able to find out some other required information to be able to complete that task or that project based on the scope of work. So I said now for examples of geospatial data, we have a lot of them, but I only picked a few. So I said we have one which is called remote sensing. Now, when we say remote sensing is a method in surveying and mapping, a method in geospatial technology, such that we are able to map a particular place without needing to be there physically. Like I used the example of forestry, whereby you know that there are a lot of dangerous animals in that forest, and it is required of you to map that forest. The best bet that you can go with is using geospatial data of, oh, maybe unmanned area vehicle to be able to map the forest without needing to be there physically. So it helps you to be able to determine terrain by using LiDAR. It gives you the ability to determine the terrain of that particular place, and also be able to get the required information of that particular place without needing to be there. At the end of the day, the data helps you to generate a 3D representation of the real world of that particular place. So that is one of the beauty of geospatial technology when it comes to getting geospatial data. Another one is also vector. Now, vector is also another means or example of geospatial data. When we talk of vector, we are simply talking about points, lines, and polygons. These are the basic things that makes up all the drawings, all the maps that we have in the world. If you want to draw, you want to create a map of Nigeria, there's going to be series of lines joined together, series of points to determine, oh, maybe trees or the likes, a series of polygons to determine the water bodies. Then at the end of the day, the boundary of Nigeria itself will be depicted by polygon. So we use the combination of points, lines, and polygons to be able to determine this location. So because points will be able to give us, oh, this particular point is depicting, oh, the XYZ of this particular object. And when you are dealing with line, oh, maybe, oh, you want to determine the coordinate of, oh, a car moving from a particular point A and going to a particular point B, and you want to join them, have an adjoining line that joins them, that okay, it's moving in this particular direction. Then maybe for monitoring system, that okay, oh, okay, what range of time does this car move from this point to this other point? So by determining the coordinate of the initial point, determining the coordinate of the end point, then the line in which the car passes, or so which we can also call the road network in which the car passes. So it can help us to determine a lot of information at the end of the day concerning the feature that we are working with based on the scope of our project. So other examples are also satellite imageries. The beauty of satellite imagery, especially the high resolution satellite imagery, is also a type of geospatial data because the satellite view our world from space. So as a result, it has the full glance of the whole world at a particular time due to the epoch of time that it releases its signals to that particular point. So the satellite helps us to also gather a lot of geospatial information data about a particular place. And in research, we usually use satellite imagery to be able to do some comparative analysis, maybe in derived satellite bathymetry and many other things. So we are still going to talk about many of these things when we get into the scene of the technology itself. Then now in population data, in census data, we now use geospatial data to be able to determine geographic areas. And that's the reason why you see that most of in election time, during election time, you discover that more of geospatial data, maps, histograms, and the likes, they come to play. Why? Because they've discovered that it is easier to depict or to make people understand what is going on by the use of maps. And the only way you can use map is to be very accurate and sure of the geolocation information that you are using. So it makes the talk to be more less, and the scene to be more efficient and active, because the map says it all than you talking and talking over time. So this take us to who uses geospatial data. Now, I'm not going to dwell too much, but I'm just going to, summarize all this. Now, we have different industry that uses geospatial data, especially industry in which the location of a point, the location of lines, and the certain location of a polygon, which we can call maybe the boundary of a land, the boundary of a farm, the boundary on a certain expanse of water, because these information are very, very crucial to measurement. They are very, very crucial to determine or depicting some level of information that is required. Maybe for oil and gas, okay, you want to be able to know where a particular oil block is under the water. It's not you can't use any form of assumption to be able to depict that particular type of information. It requires some level of devices, of technology that can give accurate information concerning the geospatial uh, detail of that particular point. So, and as a result, the some of the industries that I've listed here in construction, in building alignments, in building bridges, in constructing roads, any form of infrastructures, your geospatial data is very, very important and very, very highly used in this area. In surveying and mapping, it is also very, very key to use geospatial. In fact, it's the most important when it comes to surveying and mapping. Now, in safety and risk management, it is also used to be able to identify hazard. Now, in most advanced countries, they now install monitoring systems even on very tall or rise buildings, or even maybe mountains, so as to be able to determine hazard. Oh, to be able to know, what is the changes in the weather, to be able to know, what is the changes in the flow of water concerning, maybe a possible tsunami, a possible overflow or overflooding of the water body, ocean, into their cities. So the essence of geospatial data is also very valued when it comes to safety and risk management in mining and exploration. Definitely, geospatial data cannot be sidelined. The same thing for disaster management, as I explained. The same thing in transportation and logistics, as I said. Oh, you want to monitor a particular car moving from this particular place to another place for delivery. I want to be sure that that driver is actually going to where it ought to go to in time. There are sensors that has now been incorporated into GNSS to be able to ensure that this geospatial information from one place to the other, and also being able to calculate the timeline in 4D, has been made available by the technology and the evolution of this technology. Also in urban planning, you want to plan a city, you want to remodel a city, it is also very, very important that geospatial data is very, very uh, 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 used in this particular sector too. So the key components in geospatial technology, basically there could be many, but I'm going to just talk about just these few because they are the most common. Now we have the LiDAR, the light detection and ranging technology. Now, what the LiDAR does is that it emits some laser beams, and by the emission of these laser beams reflecting upon a particular surface, the moment it hits that particular surface, it has the capacity to be able to generate hundreds and thousands per seconds of point cloud. And when we say point cloud, that is a series of points across a particular terrain that has the capacity to determine the digital terrain model or digital elevation model of that particular place. Now, that is one of the key advantage of technology. Like I was explaining in forestry example, and you want to be able to depict a very, let's say, maybe 100 hectares of land of forestry, and you want to be using the conventional method of carrying a total station and be moving from point to point. Before you know it, an hippopotamus can just come and carry you away and throw you somewhere, or a snake that is just lurking around somewhere might just drop on the person and can cause some serious injury, or maybe a lion from anywhere can just. Now the essence of LiDAR makes the work not just not being there, but also make it efficient. Something that you will use maybe 1 year to be able to map, because of a conventional method of geospatial technology, uh, can actually make it more easier to be able to achieve this within maybe few days, maybe few days. if you want to even take more or over sufficient data, in few days you can be able to achieve this because it can pick millions of points at a glance, just at a single beam hitting that particular surface. Millions of points are taken. Then we go to another one, which is the GPS, the Global Positioning System. It's also one very key geospatial technology that has been evolving. It has been evolving over the years. It has been evolving over the years, and through this global positioning system, satellite data feeds into GPS, and the moment it feeds into GPS, it can be used for global navigation. So, and that's one of the key component that makes us to actually have the geolocation. Now, because of this GPS and also other satellites, oh, now we have Beidou of China, we have QZ SS of Japan, we have Galileo of Europe, and many others. Now, this helps to be able to ensure that the geolocation coordinates components that we require to be able to know exactly where we are, exactly where an object is, uh, has been enhanced over time and has been made available also on most of the new device. And since 1993 till date, there has been modern improvement, modern evolution when it comes to the use of GPS. The beautiful thing is, even on our mobile smartphones, we can even be able to determine our location. And this is because of the evolution in GPS, using satellite data to be able to feed us of wherever we are or wherever we need to go to. And that's the reason why we can easily be confident in our Google Maps to take us from a particular location to another particular location without us being lost along the way. And the final one that I'm going to talk about under this component is the GIS. The GIS means the Geographic Information System. Now, this combines maps with a database of other descriptive information. The other time I was talking about, spatial information, then attributes information. Now, when it comes to GIS, you are dealing with the two at the same time. Because as much as we need the spatial information to be able to know exactly where a particular place, where a particular object is, we also need to be able to differentiate from object to object. We need to be able to say, oh, this particular object is a tree, this particular object is a car, this particular object is ocean, this particular object are humans, this particular object are buildings. And that is the beautiful thing about the GIS. It has that capacity of combining this database of the spatial, that is the location of that particular object, to the attributes, so as to be able to analyze any locational information concerning the project or the scope of project that we are dealing with. So, you know, geospatial technology and data touches almost everything, because now, like I said, that we are now in a smart world. We are now building smart cities. We are now of the expectation and opinion that everything should go AI, technology, machine learning, and the likes. And geospatial technology itself cannot be sidelined, because geospatial technology enables the collection of information, and this data collection is extremely valuable, using technology to gather location information to provide us data that can give a deeper understanding of many issues. So this spatial data can answer questions and help with prediction, analysis, and decision making. So I came up with this quote because it can give us a glance of what is expected from us. Because the essence of technology is to be able to answer a particular question. And when it comes to geospatial technology, is answering a lot of questions when it comes to prediction, the essence of monitoring system, when it comes to analysis, the essence of mapping, the essence of guidance system, and also when it comes to decision making. Oh, you've gathered all of this information. What decision can I now make from this? Oh, can I now say that these points that have been given to me concerning the seabed can actually depict that, oh, there is oil block in this particular place. Oh, that I don't need to go to another place to go and get oil block. So I have sufficient oil block. So it helps decision. And also when it comes to construction, it can also help decision in, oh, do I need to build a few more stories, or do I need to stop at this particular point? So these help us to determine the capacity of what we can be able to do with the output of the data that is being gotten through geospatial technology. So I'm going to leave us with this before we move to the next phase, that without the innovation of geospatial technology, our daily lives without the innovation of geospatial technology, our daily lives could be very different. And that is true. We often don't fully appreciate how much impact these advances have on the development of spaces, buildings, natural resource management, and much more. Geospatial data is vitally important to our world, and we hope we've managed to help you appreciate some of the reasons why. So geospatial technology is the next phase, using GNSS, using incorporated AI and machine learning and some key top softwares into GNSS to be able to determine location, to be able to help us in good predictions. Okay, hurricane and all these things in developed worlds, to be able to monitor them. It is because of geospatial technology that has helped with the incorporation of some other AI functions and machine learning functions, has helped to be able to ensure that these issues, disasters, risk, development, enhancement, resource management, coastal mapping can be well predicted, analyzed, and a good decision can be made by those that are involved. So now I'm not going to use the company I represent to talk about as a case study, to be able to talk about, okay, these technologies, what are they? You know, I've been doing a lot of theory and the likes. Okay, what are these technologies? What are they? So now we are going to be seeing a few examples of these technologies, the evolution and everything with respect to CHC, who happens to be a manufacturing company for series of these geospatial technologies. So now I'm going to be starting by playing some video, as I said from the beginning.
Hello, sir. We can't see
Yes.
the video. The video is not visible, but I can hear his sound. The video is not visible. I don't know. Your slide has not been moving too, so I don't know. I can see your pointer. You are telling, but the video is not visible yet.
Okay. Maybe I'm coming. Let me do
Okay,
some.
okay. I think it has changed.
Can you see?
Yes,
Okay.
yes, yes. I can
I'm
see
coming.
buildings and all of that.
Let me come back to that place. Coming. Let me share my screen instead. Let me share my screen instead of window. Yeah, can you see my screen now?
Yes, 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 yes. Okay, sir.
Is the video moving now?
Yes, yes, yes. The video is moving. The
Okay.
audio, everything is good.
Okay. So now this is CHC using AI robotics to be able to make uh, different products that are required for different industries in geospatial technology. So first is the mapping. Sorry, I want to take this away from. Okay, so we go back. So in mobile mapping, these are the technologies that are now very much available, which has incorporation of LiDAR to UAVs. to be able to determine area terrain model. Now, in surveying and engineering, we have series of improved and upgraded GNSS solutions. Now, GNSS solutions help us to be able to determine location of a particular point. Now, the advancement in it is that it now has the capacity of video surveying to be able to determine them. Also, there are improvements in geospatial technology when it comes to uh, GIS, when it comes to marine also. So, to be able to make sure that we can determine the depth of a particular expanse of water without even really needing to be on a particular boat and be the ones manning it to that particular boat. So we now have the advancement of just technology to be able to go all by itself, monitored when excavators. Now, guidance systems have been designed through geospatial technology to be able to control this machine, to be able to do or to level all by itself, as long as you set it to whatever depth or whatever thing that you want to achieve. Then what actually brought us together, the precision agriculture, is also an advancement in geospatial technology that has been able to also use some level of guidance system to be able to get the required information that we want to achieve on that particular expanse of land. In navigation and infrastructure, geospatial technology has also been used for monitoring to be able to determine position of any particular object or the movement of a particular car through sensors from place to place. Okay, so we move down. So with the need to ensure that there's improvement in geospatial technology, now CHC being our case study now is now currently, as of 2023, the number one among Chinese manufacturers when it comes to China, and currently number three worldwide. Even we are driving all of our efforts to even becoming number two in no sooner time. And this is the current market leaders. Now, maybe many of us we know of Trimble being number one when it comes to uh, all these product line and geospatial technology. So Trimble still remains number one, and Leica number two, and CHC in number three. Now, for today's presentation, we'll be looking at some of these topics together, and I'll make it as brief as possible because I've used some videos to be able to make us to see what is actually going on in the geospatial technology world based on evolution of today. So, just a few corporate overview. Now, CHC is a technology-driven company. Anything about using GNSS advantage to be able to improve technology of being able to determine location, precise mapping, and position. That is what CHC is all about. So we are not just limited to we just want to use GNSS, okay, connect to some satellites, then determine point by point observation. No, we are like, oh, how can we be able to use these GNSS attributes and characteristics to be able to do much more than what it is being done some 5, 10 years ago. So, and as a result, this has made us to grow in a way that is actually very fast, with four major industries that we have keyed into: the geospatial industry, because we know that it is very, very key when it comes to building smart cities, smart world. And we look at the navigation industry, sensors added to cars, and that's the reason why you will see the likes of Tesla and the likes of some Xiaomi cars now that can now be driverless, so taking you from one particular point to another point. In construction, because there's no way that if you are going to get the accurate alignment in construction, it is very, very required for geospatial technology to be fully embedded. And finally, in agriculture. So these are the four major industries that CHC has keyed into to be able to produce geospatial technology that meets the demand of these industries. And across over 130 countries, we've been fully functioning and one of the fastest growing companies in the geospatial industry. So we have our vision, like you saw it in the first slide, to build a smart world with precise information, with precise information. So that is our vision, and we have our mission, no matter the challenges, to be able to achieve this together. So, and this continuous technology journey involves all this: the GNSS, the LiDAR, the INS, the imaging, the SLAM, so many form of algorithms in softwares, and even unmanned devices have been have been growing over time to be able to ensure that there is so much evolution and changes in our product line when it comes to uh, geospatial technology. Now, the beautiful thing about CHC is also the fact that when it comes to technology, now we talk about research and development, the R&D, and this company has made it to be their their focal point of investing about 18% of their yearly revenue into the research and development. And as a result, CHC is actually a company that does all of its things by itself. Everything that is embedded in all of the devices are all done by CHC with incorporation of some top experts, even from universities, professors, powerful team to be able to create a lot of inbuilt GNSS with IMU for signal processing, powerful chipset, series of algorithms, series of 3D reality image added to our LiDAR, then autonomous driving and driverless intelligent controls also. So to show that there is so much improvement to what the world was 10 years ago to what the world is today. And we are also moving with the trend to ensure that whatever we put out there are things that people can be able to relate with. So, and as a result, so we are leveraging on our own technologies as we improve. CHC was established in 2003 and till now. So we are still creating end-to-end solution. 21 years of establishment, still improving and still ensuring that the world of geospatial technology is having the evolution that it deserves in terms of newer improvements and upgrades. So when it comes to our form of manufacturing, our form of manufacturing is more of the robotics method. So just for you to understand that we understand the need for the AI, the machine learning, some level of algorithms to be incorporated in the way we couple, we fix, we repair, and we also migrate most of all of our things. So, and this gives us the room for hundreds of solutions, which I'm still going to talk about one after the other. So I'm going to move a bit faster so that we'll be able to cover. So this shows the timeline of where the company was a bit moving down the drain, but as of 2013 there was a spike in growth because we're able to diversify, not just depending on GNSS, but looking at how we can be able to use the GNSS idea and advantage to be able to create some other things, some other geospatial evolution technology that can be used in the world today. And this has really made us to grow very fast. So when it comes to global support, we have global support almost in every continent, and we have the plan to build a global support here in Africa at the beginning of 2025. So we now go fully into the geospatial solutions. for us to have an idea of what we've been talking about. Now, our geospatial solutions now are cutting edge technologies for unprecedented accuracies and efficiency. And you know, the essence of what we are looking at is when we are talking about geospatial technology, we just want to ensure that we empower sustainable development. We want to ensure that when you are making decisions for a smarter world, you are making that decision efficiently. And that's the reason why we see a lot of improved technologies. TVs are now getting better than the TVs of 10 years ago. So many devices that we buy into our homes are now getting better, more more computerized than the device that we used some 10 years ago. Even our phones, if you compare the iPhones of today to the iPhones of like 10 years ago, you will discover that the difference is clear. So if the same thing to some home appliances and gadget appliances are being looked into, the same thing also are being looked into when it comes to the geospatial world. So I'm going to be starting from the surveying and engineering. Now, in surveying and engineering, when it comes to geospatial technology, it has improved so much so that it now has an embedded need for not just GNSS smart antennas, but even field softwares, geodetic receivers, and even some total stations that have their own particular function to be able to do the mapping process of a particular job or project within a particular area at a particular level of accuracy anywhere, anytime. Now, when we look at GNSS itself, now GNSS means the Global Navigation Satellite System, a global navigation satellite system. And the GNSS has the capacity to be able to track a few satellites a few satellites to be able to determine the location of a particular place. Now, GNSS initially is used to be able to get point by point measurement. Oh, this particular point, then to that other point, then to that other point. But now today, it is now more than that because even some level of technology have been added to GNSS, that a GNSS now has the capacity of being embedded with some video cameras to be able to even determine 3D models, to determine 3D models. So, so that I will not talk so much.
The CHC Nav I-89 Pocket Visual RTK, compact, efficient, and pocket-sized with built-in dual cameras, powered by ISAR 2 technology. Premium dual cameras deliver unrivaled surveying accuracy and efficiency. The I-89 includes a visual surveying mode to extract accurate 3D coordinates from real-world video. The I-89's visual survey modifies accuracy and efficiency, enabling measurements in GNSS obstructed, hard to read, or hazardous areas. The I-89's video photogrammetry feature enables the seamless creation of 3D models of buildings and facades. By capturing short videos, the I-89 automatically associates the images with host data to generate accurate 3D models using popular 3D modeling software. With its auto-IMU, the I-89 issues accurate measurements without the need for manual initialization. Experience the I-89's one-stop stakeout process. Follow the eye-catching AR visual arrow, monitor real-time distance readings, and painfully precise scape-out positions with a clear red dot. The I-89's visual navigation and stakeout reduce your workload by up to 50%. The I-89 offers an impressive 16.5 hours operating time and a fast 3-hour battery charge. Its IP68 rating makes it ready for the everyday field work.
So, in surveying and mapping, we can see that when it comes to the using of GNSS to be able to determine points, it has gone beyond just putting the instrument on a particular range pole, then going from point to point. It can also be able to do some visual performance of 3D modeling all at once and be able to model a particular object or a particular structure. So the next geospatial technology device that is now in vogue is an Android tablet, but it is not like, oh, maybe a phone. It is more than that. Now, because these tablets are specifically designed for what we call the GIS uh, project, so the Global Information System project. Now, the geospatial technology has made us to be able to look at, oh, how can we incorporate GNSS into mobile devices for us to be able to determine position of a particular point without needing to carry so much instruments to site, especially when we need it for inspection. And as a result, these Android tablets, that we carry about has been used to integrate this technology into it to be able to give you a higher accuracy when it comes to mapping or determining the position of a particular place. So, so this is the tablet. It looks like your normal phone tablet, but it does much more than the phone tablet because the geospatial technology has been embedded in it to be able to determine position, to be able to be used for inspection in different series of project logistics and the likes. This is it being used for inspection. It has a camera of its own to be able to determine some 3D, so you can see. So with that tablet, you can be able to map out in centimeter accuracy a particular uh, area of land, and it is durable. So this shows that apart from the GNSS area, geospatial technology has even been incorporated into our tablets. Then we move to the next area uh, that we have geospatial technology now fully incorporated. We call that area the 3D mobile mapping. When we say 3D mobile mapping, then that means, oh, we are talking about the XYZ of a particular point, either on ground or above the ground or underneath the ground. Now, this 3D mobile mapping today, apart from the GNSS, what it does now is now incorporated with LiDARs, light detection and ranging devices and technology to be able to map a particular area more efficiently without you needing to get many points. So a single position can actually help you to map series of points in point cloud at once, which has made work to be more efficient, to be much easier, and to be much faster when you are using this type of technology. So for us, in the 3D mapping mobile 3D mobile mapping devices. Now we integrated a SLAM scanner which uses LiDAR technology to a GNSS RTK. So as much as you are getting the 3D terrain model of that particular place, the GNSS is also helping you to stay within or to be able to have the geolocation of that particular point. So, which makes the level of geospatial technology in this particular area of surveying and mapping to have gone much more higher than a few other components in surveying and mapping. And most other companies also are fully integrated into this particular aspect of the 3D mobile mapping. And this is one of the tasks that we carried out using this particular mobile mapping device. So moving on a bike. So with this mobile device along the road, and it's being able to map out all of the points, all of the points by the side and the left of that particular road, showing the trees, showing how the road is, just by attaching it to a bike and moving along the road. So we are able to get all this information.
As development of surveying and mapping
Now,
technology,
this video will
laser
help us
scanning
to
techniques
understand
already has been
this.
seen and applied in most surveying scenarios. What different experience does the combination of laser scanning with GNSS can bring? CHCNIF RS10 takes you to experience an innovative surveying method. Representing 20 years of CHCNIF GNSS technology development equipped with the fourth generation air dielectric GNSS antenna. Satellite signal quality improved by 20%. RS10 provides RTK positioning accuracy of better than 3 centimeters in challenging environments. Combined with the system's high-precision LiDAR and 3 HD cameras, it fuses RTK, laser, and visual SLAM to deliver 5 centimeters absolute measurement accuracy. Equipped with a powerful onboard processor, RS10 provides real-time SLAM capabilities to create georeference point clouds directly in the field. RS10 can map large areas up to 13,000 square meters in real time. For industry scenarios with high precision requirements such as real estate surveying and bridge inspection, also supports optimization through Copri software. This achieves a point cloud thickness of better than 2 centimeters and a relative accuracy of better than 1 centimeter. The transition between outdoor and indoor environments is seamless, with the RS10's ability to use the same coordinate system without the need
That's the
for
coordinate
additional
system,
geofencing.
the XYZ
The
that I was talking
integration of
about.
high-precision GNSS and SLAM technologies eliminates the need for traditional loop closure, which often complicates the data collection process for handheld scanners. SmartGo software supports real-time point cloud browsing, promptly identifying issues of incomplete data, thus avoiding rework. RS10 innovatively adopts a self-developed SQC self-coupling algorithm to calculate SLAM accuracy in real time. It alerts users with green, yellow, and red warnings, prompting timely and effective measures to ensure the final accuracy of results. RS10 data can be processed and coprocessed for instant drawing extraction. One person can complete DLG extraction for 30 buildings in just 1 day, which improves efficiency of office work significantly. RS10 is a versatile solution for surveying, civil engineering, BEAM, and so on. By supporting both traditional GNSS RTK surveying and innovative 3D reality capture, the RS10 simplifies fieldwork and improves data reliability.
So this
Hello, sir. Are you there?
hello, can you hear me?
Yes, yes, yes. I can hear you, sir. I can hear you, sir. I think you're active
Okay,
now.
okay. Thank you.
Yeah.
So let me go back to the slide again. So yeah, as I was saying, I said now in the uh Now we are on the third aspect of where geospatial technology has been embedded into. First, we talked about the surveying and engineering when we looked at GNSS. Second, we talked about the GIS using mobile tablets integrated with GNSS technology, incorporated with some AI softwares to be able to ensure that the determination of points for inspection and every other thing are well acquired. Now, third, we are looking at the category of the 3D mobile mapping. And when we look at this RS10 of CHC amongst other brands, we look at it such that you see that it's not just about using GNSS to get point by point, but as you move, because of the LiDAR, you are able to get cloud points at once of a particular expanse of land within just a few minutes. So something that you would have naturally used maybe a few days to achieve, in few minutes, you've achieved so many points, so many data that you can deduce your final information from. So, and the level of high accuracy, the 3D reality capture, everything is top notch based on today's level of technological advancement and evolution. So now, apart from the one that you use with your hand to move, we now have, even for the 3D mobile mapping system, having a second category of the airborne. Now we have one whereby you are just the one moving from point to from across the particular area. But now we now have the one whereby you just attach it to drones, and the drone will be able to fly across that particular area as designed on your screen to be able to achieve the result. You know, I was talking about forestry the other time, that oh, you want to map a particular place and you don't really need to be there. We call it remote sensing. Now, the technology of remote sensing is also applied in this airborne LiDAR system, and we can see. So this is the professional multi-rotor drone, the smart flight device, everything attached, the area survey cameras, the required software, everything has been upgraded over time to be able to achieve this. So now, the fourth aspect in which geospatial technology has created so much improvement is also in marine surveying. When it comes to marine surveying, being able to determine the depth of water, being able to determine the features of seabed. You know, not many of us can be able to swim all the way down to the Atlantic Ocean. In fact, it's not even possible because it only has a few distance that you can go before you'll be totally out of oxygen. So, and even with all the oxygen mask and all the gas oxygen behind you, there is still a level of depth that you can go before you will be totally either out of luminosity, you will also be out of the oxygen that you have. So technology has been able to help us to determine the depth of these places no matter how deep they are. And that is the advantage that we have with the growing rate of geospatial technology today. So the fourth category that has improved or created an improvement in geospatial technology is the marine surveying. And for CHC, we have a lot of products that also helps us to understand more how this technology has been used to ensure the accurate determination of depth and features of water bodies. So we have our own USV incorporated with echo sounders, incorporated with the GNSS itself, incorporated with some other beam ADCP to determine the velocity of water for hydrological research and many other things. So these are geospatial technologies integrated to be able to ensure that every information that we need to get concerning water is also readily available to be used. And this also cut across some other top companies like Trimble, like Laker. So they also have this also being able to do them. So this is the USV that I was talking about, the unmanned survey vessels, whereby it is fully integrated with every uh, device on it, and you don't need to be on water. You just need to, set the boundary that you want it to cover. Then you send the machine out, and it goes out to do it. Now, the third one, you can see that it's like a screen. Now, that one is what we call the echo sounder. In case if maybe you actually want to be the one to acquire this data by yourself, now you use this particular echo sounder. That means you have to be on water yourself. You mount it, you mount the transducer to the side of the survey boat. Then you make all your connections with cables. Then the device itself start measuring the depth of water as you move along what we call a sail line. A sail line. So this is just talking about our latest approach when it comes to hydrographic USVs, and I'm just going to play a video to that effect for us to have a clearer understanding. So you can see the boats already integrated. The GNSS is there. The powerful battery is there. The echo sounder is attached. Can you see the GNSS even with IMU? So that no matter how tilted it is still going to give you the accuracy of the position of it. So you see, you don't need to go to the water. So you just send it out. And it has been integrated so that if it comes in contact with a collision, an object, it will move away from it by itself. So it can adapt to any type of water to be able to, be stable, hovering on it, and determine the points required, sending information back to the office so you can see. So this is the screen where you are at the shop, monitoring the movement of the boat. So, and it's also sending the information of the depth back to you as it's going. Can you see? So you are monitoring. So someone is monitoring it in the car while the boat is doing its own work of determining the depth and features under the water. So this is geospatial technology in action, applicable even in the marine industry. So I move quickly to the next one. The next one we call monitoring. In monitoring also, geospatial technology has been fully incorporated. Remember, we started with the surveying and mapping GNSS. We went into GIS, looking at how geospatial technology is used there. Then we went into the 3D mobile mapping. Then we just concluded the use of geospatial technology when it comes to marine. Now we are currently on monitoring. Now, for monitoring, it is very, very important, especially in some countries that have high risk of disasters, or either maybe some dam possibly breaking, some tsunamis, hurricanes, issue of higher rainfall that might cause flooding, issue of the unstable tidal heights of their ocean and the likes. So there is need for real-time monitoring over time so that they can be able to detect that, oh, there is an issue here, and the moment they discover that issue, it can be so easy for them to instruct the citizens living around that area to quickly flee or be quickly migrated by their government to a place that is going to be safe for them. So the geospatial technology has also been fully incorporated to ensure that this monitoring phase can be done. And when it comes to CHC, being the case study that I'm using, so we have integrated the geodetic GNSS receiver even with another geodetic GNSS antenna that we place out there. Then we use the combination of the two to create a GNSS monitoring receiver. And with this GNSS monitoring receiver, it gives information that depicts any changes within that particular area in real time. So that is, oh, maybe hurricane is coming. Even before the hurricane gets to that place, the hurricane is far away because it can cover a distance of about 50 to 60 kilometer in terms of radius. So it would have sensed it like, oh, something is looking like hurricane like some 60 kilometers away. So it will give the government ample time to be able to quickly migrate a citizen away from that particular place. And for China, this type of monitoring system have even been installed even on Mount Everest, so as to be able to help them to detect and to monitor a lot of hazards around them, for them to be able to quickly beat the issues that might affect their citizens. And many other countries in Africa are now incorporating this. In Nigeria, we have a few of these monitoring systems, which we call core stations now in Nigeria, but we still use it more for us to be able to get correction data for our GNSS. We have not really implemented it in the aspect of monitoring as expected, but hopefully we know that in sooner times we can get to that particular point. So the same thing that I explained. So the essence of the monitoring also gave room to the essence of positional services, the core station and RTK network in the geospatial technology. So as much as you are monitoring, you are also getting some positional services whereby you can be able to get correction to the particular data that you've acquired in terms of geospatial information. So I'm moving a bit faster because of my time. So we are now on precision agriculture. Now, today we are talking about driverless farming. We are talking about how to make farming more easier, especially when you are dealing with a very large area of land. Now, we want to enhance planting, we want to enhance watering, we want to enhance harvesting. That is the thoughts of a modern day farmer of today. How to make what I want to do, what I want to achieve, how to make it faster so that I can be able to get the crops out there for me to get revenue in time. And this has brought us to the terminology of the precision agriculture. Now, in geospatial technology, precision agriculture has also been one other phase in which geospatial technology has incorporated itself to also help farmers to be able to achieve enhanced planting, enhanced watering, and enhanced harvesting. And that's the reason why we have some powerful drones that are now being used for irrigation of large area of land, or even being used for fertilizer. And when we come to some other aspect of precision agriculture, we discover that the essence of this is to promote sustainability and to also help to achieve higher productivity and environmental stewardship. And when it comes to CHC, now we looked at the area of precision agriculture implementing and incorporating geospatial technology in the aspect of what we call the auto steering system with a centimeter accuracy. So now the auto steering system is more or less like a system that creates a guidance to a tractor or a farm machinery and help it without it being driven, driverless, without it being driven. It helps it to be able to do the operations that is required of it on that particular farm. And as we can see in this picture, we see that there's a tractor that is expected to move along a particular line so as to create ridges where seeds can be planted into. So in this auto steering system, it comprises of just three features in its level of advancement in geospatial technology. the screen itself, where you can be able to, check the agri software. You can be able to set some things, the direction you want it to go, the place you want it to cover, which is also, like I said, a function of the coordinate system. And because of the function of coordinate system, so the GNSS is very, very important. And the third one is the GNSS that is placed on the tractor. So the GNSS is placed on the tractor to ensure the position of that tractor as it's giving information back even to the screen that is beside the steering. Now, the auto steering itself is attached, removed. We remove the steering of the tractor itself to replace it with our own steering system, so that these three devices can connect to each other and create or ensure the driverless farming of that particular tractor. So the only thing the driver just needs to do is to sit there and to start the engine. The moment the engine starts and the screen is told what to do and it's keyed in to continue the process, the tractor itself will move in that direction to do whatever it is assigned for it to do. And when it gets to the end, the next assignment for the driver is to turn off the engine. So the driver only has to work to turn on the engine and to turn off the engine. The driver does not need to drive anything, does not need to move the steering. The steering moves automatically with respect to the other two devices attached to it. That's the level in which geospatial technology has gotten us when it comes to precision agriculture. So I'm going to play a video for you. So that is them replacing the steering. So you have designed the movement already. So it moves along it and does the work for you. Can you see there's no driver there? So using GNSS to be able to achieve this, no driver, no driver. And it's compatible with almost all type of farm machines. So you just set the direction, the level that you want it to dig to. Just set it and it does the job for you. So, and this has given CHC especially the strong market adoption, because it is now very, very appreciated in top countries. In fact, in Japan, we've sold about 3,000 of this device in Japan and about 10,000 of this device in Europe. Just alone in Morocco, we've sold about 10 of this device to farmers, and even in Uganda, about another 5. Then in Zambia, in fact, it was operated by the president of Zambia. About 5 has been sold in Zambia. And we also hope that we can be able to expand this technology amongst farmers to aid precision agriculture. So I'm also going to show us a video of the installation guide for us to have an idea of what we are talking about. So everything is in one box. All that you need to put on that tractor or farm machinery, they are all in one box. So we ensure that the vehicle is in good condition using its own normal steering. So then we remove the steering, remove the steering. So to fix in our own auto steering system. If you're able to get this device, we have technical persons that can come around and fix it for you at no cost at all. So we're fixing our own steering. So after the steering, then we fix the receiver. So the receiver that is able to help us to track satellites for us to keep that farm machinery to position. So then the next thing, so the display. So then there's a camera that is also installed. So that helps the device to be able to see where it's going to. So then finally, because the device needs to be powered, so we power it from the battery of the tractor itself, just to the screen, to the steering. So connected to the screen, connected to the camera, so attached to the screen. So connected now to the steering. And everything is set. Everything is set. And from there, you can start your farm machinery. Now, in times past, this particular aspect of precision agriculture was actually through hydraulics. Now, the Trimble of like some 5 years ago used the hydraulics, needing to go through the hydraulics of the tractor, and it takes a long process. It requires some specific level of expert. But as of today, Geospatial technology has made it to be more easier to install these things without needing to go through the hydraulics. Now, all it needs is just a powering system, and the powering system from the tractor or farm machinery is sufficient enough to be able to make the device to work. So then we look at our some other aspects in which geospatial technology has been fully appreciated. So, and that is in what we call the machine control. In digital construction, machine control using this guidance system for excavators, for bulldozers, for graders has also helped geospatial technology to be well advanced, and you can see that an excavator guidance system is now very available through geospatial technology. A grader automatic control guidance system is now available. Then a bulldozer automatic control is now available. So the driver does not need to control the hands of these machines to be able to achieve what it needs to achieve. All it needs to do is to just put the instruction on the screen, and they will be able to do all the leveling work, all the grader blade work, and all the excavation of a particular depth or particular uh, uh, sand that needed to be cleared from the site. So the final aspect in which geospatial technology has been fully incorporated is the navigation. Now, today, we now have self-driving cars, so much so that it's now, when we talk of Tesla, when we talk of BYD, when we talk of Xiaomi, they are now using more of self-driving cars. And the only thing that could have made that possible is geospatial technology. So, which has created some enhanced system of capabilities. So, not just across um, some particular industry, but across almost all industry. So, to be unlocking new opportunities in the advancement of efficiency and unmanned robotic applications. So now cars are now having the capacity to be able to move from one place to the other without any driver being there to man it. Why? Because we have what we call sensors. We call them integrated GNSS plus INS sensors on board. The moment those sensors are incorporated into the system of the car, then the car can, one, be monitored, and the car can also be ensured to move from a place to place, one, without hitting any other car, without running into a tree or the likes. Even though it is still under so many evolution, there could still be some errors, but it has got to the point whereby it is now fully used and is not having the so much issues that this type of incorporation of technology had like some 5 years ago. Now, for CHC, most of the Xiaomi SU7 cars in China are now incorporated with some of our sensors for them to be able to drive themselves without anybody manning the cars. So, geospatial technology has been able to help create this, incorporation of sensors into these cars such that you can be able to have a car move from point A to point B irrespective of the network of road that it has to pass through without having any issue of being lost or being displaced along the road. So these are the sensors attached to the system of the car. And we also have the ones that can be used for industrial design, especially maybe in logistics. You have a logistic company and you expect that your driver delivers a particular product from a point to another point. And you want to also be able to monitor that the driver does not go to another place entirely or is not stopping at his girlfriend's place when he's supposed to be doing his work. So the sensor for industrial use helps you to migrate from one point to another, monitoring it and ensuring that there is timely movement of that particular vehicle. So these are the navigation application. So you can see the logistic company. So the uh, tracking devices and the likes. So this makes us to understand that when it comes to geospatial technology, it is not limited to where it can be used. But these key areas has been highlighted based on the area in which the company I represent, CHC, has also been able to, provide solution for. First in GNSS for surveying and mapping, second in GIS for our mobile and rugged tablets for inspections and for determination of points at a centimeter accuracy, in 3D mobile mapping, either by using the ant slam walking across to be able to get thousands of cloud points of that particular area, or using the airborne mode to be able to map areas in which maybe by risk you cannot physically go to, or maybe the land is of large expanse. Geospatial technology has been implemented in marine, also in precision agriculture, in machine control for construction, and also now in the navigation system of cars from point to point, place to place. So for us at THC, so we've embarked on a journey of unmatched precision and innovation. We are here to answer any question and explore our partnership, which can transform your operations. So thank you so much. Thank you so much. Thank you so much.
All right. Thank you so much, Mr. Noah. To tell you that I'm heard will be an understatement. I'm completely blown away with your technologies, yeah? And this is damn amazing. I mean, this is a whole lot of machine learning and artificial intelligence. I mean, making life easier for all. I mean, it's having application in all industries, not just agriculture or surveying alone. So this is damn amazing, sir. So we've gradually come to the end of the presentation, but now we are presently in the question and answer section. So, in case any of our participants here have questions, I want to quickly ask. Okay, so my question is the CHC nav solution, the auto steering system, can it be like it can work with existing technologies like tractors from other companies or other products, so whereby they can just discard that and put in the CAC auto steering system and it's still definitely going to work, or is you just have to get CAC tractors for it to work?
Thank you so much for the question. Actually, CAT does not produce tractors. We only produce
Okay.
solutions that help tractors to be able to have a guidance system for precision agriculture. And that's the reason
Wow.
why you will see that in one of the installation video, even the steering of the tractor is replaced with the steering of CHC. That's the only thing that we need to replace. The tractor is the tractor. And now the advantage that CHC has also had is that it has been well tested such that we don't really have limitation to any tractor. And if there is going to be limitation to any tractor, so we can have
Yes.
our technical people come on ground and we can look at how we can be able to tweak the SDK or API of the system to be able to function with respect to that tractor. You understand? So
Okay, sir.
we provide the guidance system to make the tractor to be more efficient in terms of doing the job without so much calculative work of okay, you want it to go on a precise line that you have designed, and you don't want, the driver can make a mistake and might be too tired and might drift to the, so there might be zigzag line.
Yes.
Whereas for a large expanse of land, you want the line to be as accurate, as straight as possible. So the moment you design that into the screen and you give the tractor the go ahead to proceed, so the driver just needs to turn on the engine, so that the tractor moves along that line correctly to the end of the line and turns by itself to
Wow.
to the next line and continue like that until it finishes. So it even makes the work to be easier and faster, because something that maybe through somebody being stressed out can do in few days can most likely be completed maybe in a single day, depending on the expanse of the land.
Wow. Sincerely, this is a very great innovation. This is a very great innovation. And I am also expectant of what the future holds because I know this is going to require a lot of upgrade and advancements. Like you said, your company has actually been looking into upgrade and advancement from time to time, and I think this can only get better. So life is going to get more easier, and work is going to be done in a more smarter and efficient and precise way. So thank you so much for accepting an invitation to speak here. I learned a whole lot from the videos you shared and all the presentations, and this is an amazing innovation, so I must attest. So I'm trying to see if we have any other question from our participants. Okay. Um, okay. Okay. We don't have any question from our participants streaming from YouTube and uh, LinkedIn. So, okay, thank you very much. I think this is past 3 already, so we can call it a day. We sincerely appreciate your comments, and we hope that when next we invite you, you also be able to join. Thank you so much. We sincerely appreciate and value your time and your contribution. Thank you so much, sir.
Yeah, thank you so much. Thank you so much. I really count it as a great privilege to be here. Thank you.
Okay, sir. Uh, all right. Bye for now, sir.
Yeah, bye bye.